We keep hearing ever more about climate change through the news, articles, books, and even blockbuster films. But despite these discussions, broad scientific consensus, and hard won political victories, we have not changed our trajectory towards global temperatures rising above levels most scientists agree would be catastrophic. As we all head towards this future, in this video, we explain why climate change is so integrated with the Great Transition. What we hope is that the 4Waves approach will really help us to understand the true scale of the challenge. First of all, what is climate change? By climate, we mean the average weather conditions at a global level over a long period of time. It includes everything from average temperature in different seasons, the amount of rainfall and sunshine, and the chance of extremes. The global climate was more or less stable for over 12,000 years since the end of the last ice age. It is this climatic stability which many believe made the previous Great Transition, the transition from a hunter-gatherer to an agricultural society, possible. However, in the 20th century, this climate stability was disturbed, and this disturbance is called climate change. The most obvious characteristic of this disturbance is rising atmospheric greenhouse gas concentrations and average global temperatures since the beginning of the 20th century. Other changes include melting glaciers in high mountainous regions, the Arctic, Greenland, and Antarctica, rising sea levels, more frequent extreme weather conditions such as droughts, floods, and hurricanes, the migration of bacteria, viruses, and diseases, ocean acidification and deoxygenation, a decrease in the concentration of oxygen in the ocean, an impact on crop yields, and much more. Until the 1970s, very few were concerned with climate change, and since then its causes have been the subject of many years of debate. Many theories for climate change were discussed: the influence of solar activity, cosmic dust, the movement of the Earth's poles, natural processes, volcanic activity, and more. However, by the 1980s, scientists agreed the main cause is the anthropogenic factor. That is, human activities emitting greenhouse gases and destroying forests by a third of pre-industrial levels. Particularly convincing is the tight correlation between increasing greenhouse gas concentrations and increasing global average temperatures. This is now the generally accepted concept for climate change among scientists today. Humanity has long produced greenhouse gas emissions, burning wood for heating and cooking, burning forests to obtain new territories for settlements and agriculture. But it was with the beginning of the Great Transition that a significant increase in human greenhouse gas emissions began. As we now well understand from previous videos, the first wave countries saw tremendous changes to the societies and economies in the 19th and 20th centuries as they transitioned from agricultural to urban industrialized societies. If we look at the emissions today, we can see the following. Human activity emits 4 types of greenhouse gases: carbon dioxide, methane, nitrous oxide, and so-called F gases. If we start with carbon dioxide, the main source is the combustion of hydrocarbons such as coal, oil, and natural gas, or technologies based on the combustion of hydrocarbons for energy production. As we saw in the energy video, from the end of the 18th century and throughout the 19th century, first-wave countries burned coal exclusively. In metallurgical plants, in steam engines, for cooking and heating a growing number of houses, and so on. Then, at the end of the 19th century, electrification began. Coal and oil products were burned in the furnaces of power plants to provide electricity and heat for the growing first-wave economies. At the beginning of the 20th century, first-wave countries began creating a new source of carbon dioxide emissions: burning of petroleum products, the basis of the transport revolution and motorization of the world. Internal combustion engines were used not just to power cars, but tractors and combine harvesters, airplanes, and ships. Already by the early 20th century, CO2 concentrations in the Earth's atmosphere had increased above their 800,000-year or possibly 3 million-year norms of 280 parts per million, or ppm. Almost all those emissions came from first-wave countries. Methane, or CH4 concentrations, have risen to their highest concentration in at least 650,000 years. Food production increased dramatically during the 19th and 20th centuries. Among other things, these production increases brought with them huge herds of methane-emitting cattle, from 500 million heads in 1900 to 1.5 billion heads in 2018. Rice cultivation surged, which produces methane, as waterlogged paddy fields provide an ideal environment for microbes to produce methane in a process called methanogenesis. After World War II, rapid increases in natural gas usage to generate electricity more efficiently, as well as to heat homes and for cooking, meant more methane emissions. While burning natural gas emits CO2, natural gas is methane, and leaks of this methane occur during the exploration, production, and transportation of oil and gas. By the beginning of the 21st century, these are the largest sources of methane emissions. Sources of nitrous oxide emissions include agriculture, energy use, industrial processes, and waste management. The largest source is agriculture, particularly nitrogen fertilizers production, and the use of fertilized soil and animal waste. Since the 1960s, nitrogen fertilizer use has shot up, helping feed the growing population. Increased numbers of livestock also increase animal waste, which is often over-applied on cropland. Humanity today contributes 5 times more nitrogen to the soil than in the natural cycle of the planet. Finally, despite being relatively small in volume, F-gas emissions have an outsized impact, as they are the most active greenhouse gases. Chief among these emissions are refrigerants, which are used in car air conditioners, industrial and residential refrigerators, air conditioners, and even tennis balls. And as we mentioned in our urbanization video, we can expect F-gas emissions to increase dramatically in the near future, also due to the doubling or tripling of urban populations in tropical regions buying cooling devices such as fridges and cars with air conditioners. Greenhouse gas emissions are integral to, if not the unwilling side effect of, the technologies and methods that allow humanity to move to an urban industrialized society. It is the inevitable byproduct. In the middle of the 20th century, almost all global emissions could be attributed solely to the great transition of first-wave countries. Then, second-wave countries began their transition. They used the same technologies and strategies developed in first-wave countries. They too started to burn coal, build cities, see their populations rise, eat more and more varied diets, and so on. Second-wave countries, which today include 3 billion people, thus saw new rapid increases in emissions, and those emissions still continue to rise. India and third-wave countries began their transition in the late 20th century, while fourth-wave countries are only just beginning now. And as we can see from our videos on food and energy, we can expect demand for food and energy to double this century. Annual emissions are rising and do not appear to be reaching their peak. The Great Transition looks set to add even higher concentrations of greenhouse gases into our atmosphere. We have already emitted 1.5 trillion tons of CO2 emissions alone since the start of the transition, and we have already seen temperature increases above 1 degree Celsius. If we want to keep temperature increases below 2 degrees Celsius, we have around 590 to 1,240 gigatons more from 2018 levels. That is in total, not per year, but in total. This is known as an emissions budget. However, at current rates of 35 gigatons a year, we will exceed that amount by the middle of this century. Even though 2 degrees is often touted as a target, as explained, that would already be a disaster. Temperatures have risen today by around 1 degree Celsius, and we are already witnessing a large number of events caused by climate change, such as forest fires in Australia, France, and California, or hurricanes on America's Atlantic coast. Further increases would lead to exponentially more dangerous changes. And as we can see, we are not even on target for 2 degrees. When seeking to explain the choice in the first-wave countries, climate activists often present policy ideas that call for reducing annual emissions in first-wave countries. Such activists present the costs as financial, for example, investing in renewables and lifestyle changes, not flying, for example. This would no doubt be helpful, but is quite far from a solution. It fails to address the most important aspect of climate change. Emissions, as we have seen, are cumulative. The first-wave countries have already emitted those 1 trillion tons of CO2 equivalent to urbanize 1 billion people. The climate is already broken, and the citizens of third and fourth-wave countries are still in the early stages of their transition. Reducing emissions in the first and second-wave countries may be feasible, but what about the 6 billion people in the third and fourth-wave countries, including the 2 billion yet to be born that have yet to complete their great transition to an urban industrialized society? Their emissions far exceed the remaining budget of emissions before exceeding 2 degrees. When looking at the following graph, we should remember that in 1950, it would have been almost entirely made up of first-wave countries. Today, one second-wave country, China alone, is responsible for 12% of cumulative emissions, mostly from the last 30 years. If we look at the rising second and third-wave cumulative emissions over time, using China and India as examples, we can see the following. Fourth-wave countries form less than 1% of cumulative emissions, around 10 gigatons, as we have seen. Increased energy consumption, food production, etc. will soon see this rise rapidly. Of our total human cumulative 1,531 gigatons of emissions between 1750 and 2017, again, the first wave accounts for 1 trillion tons. The second wave so far has emitted 450 gigatons, the third wave 70 gigatons, and fourth 10 gigatons. Understanding that the countries of the third and fourth wave have yet to complete their great transition, that is 6 billion people, we can expect emissions to continue to grow. If those 6 billion were to emit the same amount per capita as the first wave, that would be an additional 6 trillion tons. And first-wave countries' emissions will not disappear overnight. Normally, this is where the explanation of our impact on the climate would stop, and we would move to explain how these trends appear to be set to continue. However, it would be a great disservice to our viewers. Instead, we need to explain that there are other ways that humanity may be damaging the climate, aside from greenhouse gas emissions. The Earth's climate system is an extraordinarily complex and still poorly understood system. Another explanation for climate change is that it comes as a direct result of the destruction of natural forests. Theoretical physicists Viktor Gorshkov and Anastasia Makariva have been working on a theory for 60 years called the theory of biotic regulation. In this theory, forests are not simply carbon sinks, they actively regulate global temperatures. In another course, we might be able to explain the science in detail. The key point is that the climate is damaged due to destruction by humanity of 50% of the world's main natural forests in Siberia, Canada, the Amazon, Congo, and Oceania, and their ability to regulate global temperatures. In other words, even bringing human emissions to zero would not be enough. We would need to restore natural forests and increase their area by 50%, or about 1 trillion trees. What is also important is that planting or mass seeding trees is not reforestation. Human-planted forests are not able to replicate this role. The forests must regenerate on their own. We need the so-called afforestation. And before we can restore forests, we need to prohibit all logging except in man-made plantations. This video would be too long if we went into detail about all the ways humanity uses wood and the increased usage of deforestation as part of the Great Transition. Suffice it to say, the Great Transition sees growth in forest clearing for livestock to wood and cellulose, used in everything from the furniture industry to packaging, newspapers to toilet paper and more. And as we have already understood, in the 21st century, we have to radically change many industries. So, our global annual emissions are increasing, and it will be very hard to decrease annual emissions because humanity will see another 6 billion people move from an agrarian to an urban industrialized society by 2100. For the same reason, we can see the world's remaining wild forests come under pressure. Scientists have informed us of the very severe consequences of a 2-degree increase in temperature. But we look as if we will increase temperatures by at least 4 degrees. We can therefore expect to see ever greater conflict between the first wave and the third and fourth wave countries over the issue. Third and fourth wave countries will not give up on their transition, especially not due to requests from first wave countries who have already emitted what they needed to complete the transition. Regardless, there is no feasible scenario of humanity willingly sending itself back into the agrarian era. In our next video, we will consider why new clean technologies are not yet available to allow the third and fourth wave to complete their transitions emission-free or with far lower emissions. Sadly, there is little cause for optimism. The impact of climate change will gradually become ever more apparent and destructive for humanity. Many have started making comparisons to the Roman Empire. It took more than 300 years to collapse, and only descendants were able to establish the moment of the beginning of the end. The people who lived at that time did not realize the scale of what was happening. In the next video, we will look at what we can expect from new technologies in the 21st century, and why humanity faces even greater challenges than the climate as a result of the Great Transition.